All right, so we're going to find dy dx using implicit differentiation. So I've got the circle of radius 4, x squared plus y squared equals 16. That's the equation for a circle, radius 4, centered at the origin. All right, so to find this, I take my steps. Step 1, differentiate both sides with respect to x. So I'm going to take the derivative, both sides with respect to x. Step 2, get all terms with dy dx on the left and move everything else to the right. So take the derivative of this with respect to x. Derivative of x squared with respect to x is 2x. Now, y is a different variable than x, so I have to treat it like a chain rule. So I have something squared. That means that's 2 times something. That's 2y times the derivative of the something. Derivative of y with respect to x is dy dx. This equals to the derivative of 16, which is a constant. That's just 0. Okay, how about that? That's pretty easy, right? Now, I want to get, in step 2, all the terms with dy dx on the left. This is on the left already. It's the only one with dy dx. So what do I need to do? I need to move this to the right. The opposite of adding 2x is subtracting 2x. So I'm going to subtract 2x on both sides. Okay? Now, the third step says to factor out dy dx. Well, dy dx is already factored here. So the fourth step says solve for dy dx. Well, to solve for dy dx, I just divide both sides by 2y. And so if I divide both sides by 2y, I get negative 2x divided by 2y. The 2's cancel, and so that's where the negative x over y comes into play. The way I think about this, dy dx equals negative x over y. This is implicit because it has an x and a y input here. So I think about this as a slope machine. You give me a point on this circle, some xy coordinate, and I can tell you the slope at that point, okay? So this machine yields the slope of the tangent line to the circle of radius 4 found by x divided by y for some xy coordinate on the circle. So let's take a point, maybe, 0, 4. So x equal to 0, y equal to 4. It would look as though that point would have some slope, 0, if I'm drawing a tangent line here. So let's see, let's plug it into our equation. Dy dx equals negative x over y, so x is 0, so that's negative 0 over y, which is 4, which is equal to 0. So that tells me that my slope should be 0 at that point, which makes perfect sense. Let's take another point, maybe say 2 comma negative 12, square root of 12. Okay, so that's the point right there. Now if I plug that into my slope machine, looks like it's going to be a positive slope. Well, let's see what happens. I plug a 2 in for negative x, I get negative 2. I plug in for y, negative square root 12. And so I have a negative and negative cancel. And then 12 square rooted, a 2 comes out and a square root 3 stays inside. And so the 2's cancel, so I get 1 over the square root of 3. Now, 1 over the square root of 3, what does that represent? That's my slope there at that particular point. So I like to think of this as my slope machine. I plug in a xy coordinate and it spits out a slope at that particular point. So there's a particular point, there's a particular point. Okay. Next problem, I want to find dy dx implicitly again. So the first thing I'm going to do is I'm going to take the derivative with respect to x on both sides. Okay, so if I do that, what do I get? Well, this first one here is a product. I do the first times the derivative of the second. The first is x squared times the derivative of the second. What's the derivative of y with respect to x? That's just dy dx. And then what do? I do the second, which is y, times the derivative of the first. Derivative of x squared with respect to x is just 2x. Okay. So I just took care of that part. Now I need to take care of this part. Guess what? It's another product rule. So it's the first times the derivative of the second. Derivative of x is just 1. Okay, plus the second times the derivative of the first. Derivative of 2y. Remember, I'm taking it with respect to x, so that means that I have to treat y like a chain rule since I don't know what it is. So it's something squared. The derivative of something squared is 2 times something, 2 times y, times the derivative of the something, that dy dx. And then this is equal to the derivative of negative 2, which is a constant, and that's equal to 0. Okay? Now, what is step 2 of my system? Get all the dy dx on the left and move everything else to the right. So what's dy dx? We got a dy dx here and we got a dy dx here. Everything else needs to be moved over. So I need to move this and I need to move that. The opposite of adding is subtracting. So I'm going to just rewrite these that I had here. And then I want to move these two over to the right. So I do that through subtraction. So minus 2xy and minus y squared. Okay, now step 3, factor out dy dx on the left. So I've moved the dy dx's to the left. I want to factor them out. So I have a dy dx in both of those. I'm going to GCF. We'll factor them out. If I factor them out, all I have left inside the parentheses is x squared plus 2xy. And then the dy dx factored out here. The last step, once I factor it out, I solve for dy dx. See how easy it is when you follow the steps here? Follow your steps, people. Now, how do I get this by itself? It's multiplication, the opposite, the inverse operation for multiplication, division. So what am I going to divide? I'm going to divide both sides by this factor here. So I divide both sides by that factor. And so those terms cancel. So what do I have? I have dy dx equals, I've got a negative and a negative here, so I'm going to factor that out. And when I factor that out, I get this answer right here. Okay? Hopefully, following the steps makes this kind of complicated system right here. It looks really complicated. But if you follow these simple little steps right here, differentiate both sides with respect to x. Get all dy dx on the left, move everything else to the right. Factor out your dy dx. Solve for dy dx. And if you follow those steps, you'll get to your answer.